Hello everybody, it's so good to see you. I've missed you a lot. My name is Miss Josie and I work at Virginia Beach Public Library. Today we're going to do a little bit of preschool STEAM. But before we do that, I need you to clap your hands. I need you to stamp your feet. I need you to wave. All right. We clap and sing hello. We clap and sing hello. With our friends at Science Time, we clap and sing hello. Next, we're going to stamp our feet. We stamp and sing hello. We stamp and sing hello. With our friends at Science Time, we stamp and sing hello. Next, we're going to wave. We wave and sing hello. We wave and sing hello. With our friends at Science Time, we wave and sing hello. Yay! Good job. So our topic today is buoyancy. We're going to talk about whether or not things sink or float. When something is heavier than water, it sinks. When something is lighter than water, it goes up, it floats. We're going to talk a little bit about why that happens, but I'm going to read you part of a book first. Our book is Captain Kidd's Crew Experiments with Sinking and Floating. This was written by Mark Weekland. It's illustrated by Troy Cummings. This book is not available on the library's Hoopla account, but there are other books about this topic. Ahoy, mate! Captain Kidd's my name. Floating and sinking is my game. Pirate captains have to know why boats float and anchors sink. So come aboard me ship, the Driftwood. Let's start with gravity. Gravity is the force that pulls all objects toward the center of the earth. It's pulling on me, you, the ocean water, and these boats, too. So why doesn't gravity pull the driftwood underwater? And why doesn't this rowboat sink like a stone? Gravity is pulling it down. Oh, because we're held up by invisible sea monsters? No, it's not invisible sea creatures, it's buoyancy. Buoyancy is the force of a liquid pushing upward. Gravity and buoyancy work against each other. Gravity is pulling down, buoyancy is pushing up. There she blows! That's no whale. It's a log floating in the water. Whether something sinks or floats depends upon its density. Density is the weight of something compared to its size. When an object is denser than the liquid or gas it's in, it sinks. If it's less dense, it floats. So the heavier, the more dense something is, the lighter, the less dense it is. So heavier things are more likely to sink, lighter things are more likely to float. Should we try that? Should we do our experiment on that? So I collected a bunch of objects here. You may have objects like this at home that you can collect to do this experiment. If you don't have them handy, you could stop the video and go get them right after I finish telling you what all you need. The things that you would need for your experiment is you need a container of water. I have a nice clear container, but you can use anything you have at home. You can use a dish pan, you can use if you have a blow-up swimming pool outside, you could use that. And you're going to fill it about 3/4 with water. I have a little line here so you can see what happens when I drop something in my water. And then you're going to need to collect a variety of items. I've got a lot of different things. You're going to want to look for different kinds of material, anything that's not going to be damaged by being dropped in the water. So let's see, what do I have? I have a wooden spool. Do I think that spool is heavier or lighter than water? It feels really light to me, so I think it's going to float. Let's find out. I'm going to drop it in the water. It went down, but it came right back up again. Look at that. It's floating in the water. All right. My next item is a rubber worm. He feels really light too. I think he's going to float. What do you think? Do you think he'll float? Let's try it. He didn't float. He sank right to the bottom. It's important for a scientist to ask questions, and it's important for a scientist to guess, to make a prediction about what might happen. And my prediction was wrong. And that's okay, because I learned something. I learned that my worm is actually not lighter than water, that my worm will sink when it's in water. I've learned something new. Oh, my next item is a ping pong ball. It feels really light. It feels lighter than the worm did, lighter than the spool. So I think it's gonna float. Let's find out. And it did. It floated. All right. I have a plastic dinosaur. Do you have a plastic dinosaur? Ah, he's really cute. But he feels, let's see. I have no idea. I have no idea. I think he's gonna float. Let's find out. He did, he floats. Yay, he floats not very well. He looks like he's walking in the water, doesn't he? But he's actually floating. All right, I have a rock. It's a heavy rock. It definitely feels heavier than water. I'm gonna drop it in here. What do you think? Do you think it's gonna sink or float? I think it's gonna sink. It did. Oh. Here's a piece of wood. It's a popsicle stick. Sink or float? It floated. I forgot to make my prediction, but I thought it was going to float because wood usually does. Now I have another rock. It doesn't feel as heavy as the other rock because this is a very special rock. This came from inside of a volcano. This is a piece of pumice, and it has lots of little tiny holes in it. And the question is, will it sink or will it float? What do you think? Let's find out. It's pretty amazing. It's floating. Do you know why this rock floats and that rock doesn't? Well, this rock, like I said, was very, very light. It's full of lots and lots of little holes. And those little air holes was where gas was trapped in the lava as it cooled. And then that air escaped, and all those air holes are just like when you blow up a toy that you're going to use in the pool. All that air helps hold that toy above the water. The air holes in my rock did the same thing. So you can get a bunch of other items together and do that experiment, but I want to do a second experiment. My second experiment involves this balloon. What do you think? Do you think the balloon is going to sink or float? It's going to float, and we know it'll float. I put it right there in the water, and it's floating right on top. Now, if I put my hand here and I push down, watch what happens to the water level in the container. It goes up. If you look at my line on the side, you'll see it went up. That's because as the balloon was pushed down in the water was displaced by the weight of the balloon, by the weight of me pressing down on the balloon. And it caused the water level to come up all around it. The water had to rise to make space for that balloon. The next experiment I'm going to try is I've made two little boats out of tin foil. Do you have tin foil at home? If you have tin foil, you can tear yourself two pieces that are just about the same size, and you can do two different models of boats. And then what you're going to need is a bunch of small things that are heavy. It could be, those things might be glass beads, they might be marbles, they might be pebbles. I have pennies. So I'm going to take a great big handful of pennies, and I'm going to start dropping them in my boat, and I'm going to see how many pennies my boat holds. 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a lot of pennies. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's a lot of pennies. What if I just took a whole bunch of pennies and dumped them in there? Oh! I don't know at what point it sunk, but it sank. So let's see. We know for a fact it held 20 pennies, but it did not hold how many pennies I have now. Now what you want to do is you want to keep counting so you see how many it takes before it floats. Let's try it again. 1, 2, 4. I'm going to count by twos. 6, 8, 10, 12, 14, 16, 18, 20, and I'm going to keep on counting till I know how many it takes to sink. Then I'm going to take my other boat. My other boat is different. This boat was a kind of flat boat with very narrow sides. This is a tall, skinnier boat with higher sides. And I'm going to see if that one will hold more pennies. So let's try it. 2, 4, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's how many we knew the other one would hold. Let's try some more. 22, 24, 26, 28, 30, 32, 34. Oh, 34. It held 34 pennies. This is an experiment you can do at home. You can make 2 different kinds of boats, and you can see how many pennies, rocks, or marbles that your boat might hold, and see which model boat will hold the most. And you can keep doing that all summer, make different kinds of boats. Things you might want to try is, you might want to try a seashell and see if a seashell will float. What do you think? Sink or float? Let's find out. Now if I put it very carefully, oh, it went right to the bottom. Some seashells will float, but not that one. How about, this is a lid to a soda bottle. I'm going to put it like this. It'll float when I put it in like that. It's almost like a little boat itself. Or I can put it in sideways. Oop, let's see, if I put it in sideways, does it still float? It does. How many pennies do you think it'll hold? Just 2. So that's some of the fun you can have with sinking and floating, with density, with buoyancy. You can find some other books on the topic. I hope to see you this summer, and my goodbye goes like this. We're going to clap our hands, we're going to stamp our feet, we're going to wave. I'm going to say thank you for watching. My hands say thank you with the clap, clap, clap. My feet say thank you with the tap, tap, tap.